this video is going to be a demonstration video. There's a story that accompanies it, and then we're going to talk about some things we can learn from the story in the demo. So, there was a guy named Ira Remsen who was a professor at the University of Johns Hopkins down in Baltimore, and he was actually the originator, the founder of the Colleges of Arts and Sciences at Johns Hopkins University. Pretty prestigious place. This demo is taken from an experience he had while he was examining textbooks for use in the courses that were going to be in the College of Art and Sciences. So let's jump into the demo. So as you can see, we've got a penny, we've got a copper plate, and we've got some nitric acid. So Ira Remsen, while examining some textbooks for use in his chemistry courses at the university, Johns Hopkins University in Baltimore, came across a statement while he was sitting in the doctor's office waiting for the doctor to show up, which takes forever and a day normally. And the statement said, nitric acid acts upon copper. And he said he was familiar with copper because of the pennies that we're used to. And he saw that on the table at the doctor's office, there was some nitric acid. And he said in the spirit of discovery, he was willing to sacrifice a penny, and he was going to borrow some of the doctor's nitric acid. So here's how the story goes. He takes the penny and he puts it down on the table and then pours the nitric acid on top. He wants to know what nitric acid acting upon a penny really means. What does the act upon piece mean? Instead of doing this on the table, and you'll understand why when we get further into the story, we're going to do this in a closed environment. So this flask has our water-like nitric acid in it, colorless, transparent, very water-like in its appearance. We're going to add in this copper foil and then close this back up. So this tube leads to a water filter that's going to separate out and filter out all of the toxic gas that is produced from this reaction. So here we go. So he pours the nitric acid on the penny, and he said the acting upon was no small change. He said the fizzing and foaming and fuming over top of the penny was immediate, and we saw that. He said a brown cloud of suffocating gas began to evolve and erupt from around it, and we see that as well. He said the cloud was very disagreeable. By disagreeable, I think he was referring to the fact that this bleach-like gas smells like bleach. It's a nitrous oxide. Irritates the nose, the mouth, the throat, the lungs. So he was very likely hacking and coughing and didn't know what the heck to do because this is taking place on the table, not in this flask. So he did the first thing that came to mind, which was grab the copper penny and the mess and scoop it in his hands and toss it out the window. Not my first choice, but what he then learned was nitric acid not only acts upon pennies and basically makes them go away, there's no penny left in here anymore, but that also acts upon hands. So his fingers were being basically burned with the acid, and in response to that, he wiped them on his pants and learned that nitric acid also acts upon trousers. So he's hacking and coughing and very likely eyes watering. His hands are burned with acid and his pants are ruined. They've probably got some big holes in them. After that, he said it was probably one of the most remarkable experiences that he had ever had, because it taught him that you need to be very intentional about the words you use when you describe things like chemical reactions. So these general statements like nitric acid acts upon a penny, we would have never been able to predict what we just saw, which is a penny essentially disappearing into thin air and this liquid that's left. It gave off a ton of heat, it gave off that brown gas, and what we're left with is this very pretty blue solution. There's no way we could have known that. There's no way that Ira Remsen would have known that. So if we think about this very costly experiment for Mr. Remsen, we can think of two things. One, we never ever want to just haphazardly mix chemicals together in the lab. And secondly, when we go to communicate what our experience was in the lab, we need to make sure we measure our words. Had Ira Remsen read nitric acid acts upon copper, releasing a gas that is toxic, irritant to the lungs and eyes, it creates a lot of heat, and the acid is very, very irritating to the skin. He probably wouldn't have done it at the doctor's office. Probably still would have done it, probably at the college, in a fume hood, where he could just watch it in safety. So let's measure our words, let's communicate clearly, and one of the best ways to do that is to always go back when you're done and reread what you've written. Think about somebody needs to have a word picture painted for them about what your experience was. Always be safe in the lab, always communicate clearly, never mix chemicals together haphazardly. Remember that. Don't pull an Ira.